Hey grade 7s. Today what we're going to do is we'll just continue on with our relations and patterns, and what we're going to do is we're going to solve equations with models. So just a reminder, solving equations, that's when you're isolating the variable, like we're trying to get something like x or a y or q by itself so we can figure out what it's equal to. Now, here's the neat thing, like last time we learned about doing inverse operations to isolate the variable, so I'm hoping all this language is really familiar to you. What we're going to do is we're going to do the exact same thing, except we're going to kind of use pictures to kind of sort out what we're going to do. So a few things that we need to do is we need to kind of come up with a quick little guide for our pictures. So if you see a square box here, just like this, that's worth x, or whatever your variable is, p or q, whatever it is. So that's going to be what we're going to indicate for a variable, nice big box. Now our circles are going to be our counters. So if I put a red circle up, it's going to be +1. If I put a blue circle up, it's going to be -1. So let's start by drawing this first equation. So the first thing we're going to do, okay, is I'm going to draw the left side of the equal sign. So maybe before we get going, let me just put a equal sign up here. Okay. And on the left side of the equal sign, you can see I've got an x. So I need to draw an x. There we go. I just put an x symbol in there. And we've got a 3. So this is +3. So I've got 3 red circles. That's +3. On the right side of the equal sign, you can see I've got 6. So 1, 2, 3, 4, 5, 6. Now, if I was doing this with algebra, I think you would recognize the first thing I would do is, when I get out my black pen, I'd go x plus 3, and to isolate the x, I would actually subtract 3 from the left. And in algebra, what I do to the left side, I need to do the right side of the equal sign. So I would do 6 minus 3. On the left side, we would get rid of that, and we're left with just x. On the right side, I would do 6 minus 3, which gives us 3. Now here's the neat thing. Over in our equation here on the picture side, what I'm going to do is I'm going to take away 3 ones from the left, which, to keep my scale balanced, I need to take away 3 ones from the right. And I'm allowed to do that as long as I do the same thing to one side of the equal sign as I do to the other. So let me get my green pen back. You can see on the left side of the equal sign, I'm left with an x. On the right side of the equal sign, I'm left with 3 ones values. So you can see pretty clearly, I think here, that x is equal to 3 ones values, which is the same as x equal to 3. So I just want to kind of hopefully introduce you to a picture so you kind of see what you're doing. It's not just symbols that you're working with, but you're actually working with kind of a picture in your head of what's happening. Now here's where life gets a little different when these two values have different signs. Okay, so let's draw it out first. So you can see I'm going to need my green. I'm going to draw an x. Here I've got 2 -1s, so I've got 2 blues. Over on the right side, you can see I've got 5 positives, so 1, 2, 3, 4, 5. If I was doing algebra here, the first thing I would do is I would add 2 to both sides, because -2 plus 2 add up to 0 using that 0 principle. And then what I'd have to do is I'd have to add 2 to this side, because what I do to the left, I need to also do to the right. Well, the same is true when we're doing it with our models. What I'm going to do is I'm going to add 2 to the left side. The neat thing is if I've got 2 negatives here and 2 positives, this is equal to 0. So it actually gets rid of it. So what I'm left with is on the left side, I'm left with just a x. I'm just trying to isolate that variable. Now here's the interesting thing here. I just added 2 to the left. So what I need to do is I need to add 2 to the right. I brought that in because if I add 2 to the left here, I need to also add 2 there. So last thing I'm going to do, I'm going to say this is equal. I guess this was equal here too. And I'm going to say x is equal to, I had 5 before, and I now have 2 more. So x equals 7. So you can see using pictures, we can get the exact same answer you would have done using just numbers and variables. Well, let's try this one here. So let's draw it out. So we have 2 x's. Kind of roll through this a little bit quicker. We've got 5 positive ones. 1, 2, 3, 4, 5. On the right side, we've got 13. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then we got 3 extras. 1, 2, 3. That makes our 13. Now, first thing I'm going to do is I'm going to deal with this plus 5. I want to get rid of these 5 ones. Well, we'd subtract 5 from both sides. Okay, that would be the first thing I would normally do. Well, neat thing here, I can take these 5s, and subtracting 5 just means I can get rid of them, throwing them out. Because these both are positives, I can take 5 over here, do the same thing, throw it out. What am I left with? You can see I'm left with 2 x's and on the right side I'm left with, let's count them up, 1, 2, 3, 4, 5, 6, 7, 8. Now here's the neat thing that's happening here. We've got 2 x's and we've got 8 over here. So 1 x will actually be worth half of the amount. The other x will actually be worth the other half. So what we can do is we can tell people here that 1x is actually equal to, in this case you can see very clearly, 1, 2, 3, 4. So x equals 4. Grade 7s, I hope this is enough to kind of get you going. Good luck. Ask questions if you got them as you work through the few questions that I gave you.